welcome to another episode of REDtalks.live. And with me, I have someone who joined us in one of our earlier episodes, Joel King from WWT. Welcome back, Joel. Great to have you back on the show.
Thanks, Nathan. Good to be here. Looking forward to Cisco Live next week and talking about some of these topics there to those attendees as well. So
cool. I think you guys are like a diamond sponsor of Cisco Live, right?
We are right inside the main entrance, and we have a special attention getter that's going to be at the show. So we're bringing a race car.
Awesome. That's pretty cool. I can't think I brought a race car to an event before, so nice. Well done there. Yeah, I imagine you've been really busy in the lead up to this, creating new content, creating demonstrations, integrations, automations, and well, you're back on now because there's an interesting thing that's come up in these eras of rapid transformation like we've got right now. So many new themes and concepts kind of get brought in a hurry that sometimes we forget to kind of explain all of those concepts. And we were talking just before we started this episode, and Joel was pointing out that things like the word code has crept into a lot of the conversations. We've got infrastructure as code. The way we manage things is using like code repository tooling, etc. But I guess in a lot of cases, when did we stop and just explain how code kind of relates to networking? It's not exactly the same as like monolithic software code, is it, Joel? I mean, what got your attention that you had to go and solve this problem?
Well, we have, as you know, we have a innovation pod where we're focusing on our F5 innovation, and we have our executives that are sponsoring those activities, and we have sales leadership that's involved in that as well. And I think sometimes we need to be a little bit more specific about what our activities are, what we're writing, what we're developing, what tools we develop it in. But you're exactly right. I mean, Worldwide owns a software development branch that is specific in primarily applications for iPhones and for iPads and so on. And they do a lot of the front end type of work. And that's a little bit different than what we do in network engineering, because we're looking more at integrations between different systems. So it's not this large monolithic code base that we're developing. There's more to it, and I thought we needed to articulate that better to our sales leadership so that they know how to position some of our activities with our customers.
That's awesome, and we're lucky enough to have Joel share what he put together, where he asked the big question, "What is code?" with us on this episode today. So, Joel, I believe you uploaded that to SlideShare, but I appreciate you coming on and giving the context. I personally really dislike it when someone just sends a deck and I meant to work out what they were meaning. It's really useful when we get the person who created that message to actually explain what the context was of those slides and kind of how it works. So thanks for coming along and taking the time to sort of walk us through this really important question in the era of kind of network automation orchestration, which is what is code? What is code to us?
So let me just pop over here. Let me know if you can see that.
I can see your SlideShare page. Yep.
And we'll expand out here.
And now we can really see it. Excellent.
Very good. So just a little bit about a little bit about me. I've been at Worldwide for about 5 years now, and been working on the SDN, the automation piece. But what I started off describing, and I look at this picture here. The vinyl binders kind of remind me of when I first got started, right out of college, working for the Navy as a civilian, but writing software for the Navy. And back in those days, we put our software in binders like you see Margaret Hamilton standing with here, and I thought about how much code you write. Obviously, there's a lot of lines of assembly language that she's standing up against there in that picture. And back when I first got started, we programmed on mainframes on Burroughs computers, and Burroughs was rather innovative in that their COBOL compiler had a one-to-one relationship between COBOL and assembly language. So it was very easy to patch programs in the field. We were allowed to patch programs but not release programs outside the release cycle. And when we went to mini computers, that relationship between the higher level language and the assembly language didn't exist anymore. But I took it upon myself to learn Perkin-Elmer's assembly, which was an IBM 370 assembler, and was able to understand and figure out how the architecture of that system was so that we could actually develop assembly language patches to our higher level programs. And what happened is I would get called into the boss's office a lot. It wasn't a bad thing. It was one of those things where out of maybe 20 programmers sitting there in the office that were good, experienced programmers, there was only one guy that had figured out how to make a few very minor changes to the programs running in the field. And I go back to one of the things that our sales leadership proposed was, doing some outsourcing of some of the innovation that we're doing for F5 and F5 automation. And I said, well, it's really hard to do that because it's not about writing thousands of lines of code. It's about understanding the architecture that you're developing in and maybe writing very little code, but is that knowledge and experience that's quite important. So in this reference here with the Apollo mission and Margaret Hamilton, I think the same thing's true. While there's thousands of lines of code here, what was most important to Apollo was the executive program, which was about 500 lines, and you can see it on GitHub, that essentially was somewhat analogous to a scheduler or a task manager. And that code was able to prioritize tasks within this big thousands of lines of assembly code that allowed Apollo 11 to successfully land on the moon. As you recall, during their landing, they had a number of alarms that came up in their guidance computer, 1201, 1202 alarms, which were some lower priority extraneous rendezvous radar interrupts that weren't important to the landing. So the point of this is that in software engineering, sometimes it's not the thousands of lines of code that you write, that is understanding the architecture and being able to write some very good and very high level architectural type designs that allow you to be very successful in what you're doing. So does that, I mean, maybe you have a similar experience in some of your background as well.
That's actually a really cool background story, Joel. I appreciate that. I had no idea actually about that level of detail in that earlier days and the assembly code. And all I could think about was how often I've adopted the fail fast, fail forward, continuous iteration. Yeah, it broke, but it's fixed in the next one that came out 10 seconds later. So let's just roll on. And how that absolutely wouldn't apply to spacecraft.
Well, it's interesting because in the reference material here on this slide share, I have a link to David Scott, one of the astronauts, and he talked about how they had actually considered allowing changes to the guidance computer up to the day of launch. And they were considering and thinking about that whole concept of being able to do continuous integration back in those days prior to Apollo, in the Apollo program. And he actually commented in that video, and I would encourage people to watch it because it's quite good. He says, "I'm really glad we didn't do that in this case." He said,
yeah, I can appreciate that. But going back to your comments earlier about the way that you architect things to make them not entirely reliant or even vulnerable to just a single thing being wrong. I mean, the very earlier days, I remember just doing something like even some basic. It did not take a lot to destroy the entire thing. Whereas actually the way things have evolved with more microservice architectures and not being reliant on these monolithic builds to be 100% right for it to work, actually you can gracefully fail and be okay with that and continue on.
And that's exactly what the scheduler in the Apollo's guidance computer did. They had a failure. They ran out of memory and CPU. That was what the 1201, 1202 alarms were. That rendezvous radar did not have memory and CPU to be able to execute, but the executive program said, that's not really that important right now. Landing is more important than returning home.
Excellent.
So let's just, if we look at another infrastructure as code concept, the source of truth. And in my research here, and one of the things that I'm particularly interested in is this concept of the source of truth, configuration data in YAML files and CSV files, in databases. We've been putting a lot of our F5 configuration in MongoDBs and driving all of our configuration out of that. But the source of truth was important back in the Apollo mission as well. The guidance computer had a keyboard display called the disk key. And as they were testing the software, they found that if you entered a PO1 program during flight, it crashed and wiped out all of the navigational data in the guidance computer. And Margaret Hamilton was testing this in the lab. She had her 4-year-old daughter in the office, and her daughter was playing with the disk key and entered a PO1 while they were running some simulations and crashed it. So Margaret said, we should put logic in to keep that from happening. And the response was, no, astronauts are trained not to make mistakes. Well, I don't know if you recall, but in Apollo 8, apparently during flight, they inadvertently entered a P01 code, which wiped out all of the navigational data that they had at the time. So back to the source of truth. Device configurations are not a good source of truth, and that's exactly the way they had architected things with the guidance computer, that there were 2 cases. Another case was in Apollo 13. As you recall in the movie, when they had to go to the LEM as a lifeboat, they had to transfer data from the guidance computer in the command module to the LEM. And they did that manually. So they were essentially taking data from one device in one computer and manually putting it in another device. So if you think about the way most networks are configured today, the device itself and the configuration on it is considered the source of truth. We're trying to encourage people to take a 180-degree view, and that is that all of this configuration data should be stored centrally and pushed down to the device. And that's a big mindset cultural change for a lot of folks. But when you go back to the Apollo mission and you realize that their source of truth for that navigational data was on the device itself, and there were at least 2 instances where they either lost it and had to re-enter it from mission control, or had to transfer it from one device to the other. This is an important aspect that people really need to be able to focus on, because it is how we actually benefit from infrastructure as code.
That's yeah, I couldn't agree more with the importance of that change, that cultural change you need to kind of adopt, where I don't assume the device is right, and I'm doing interaction with the device to ask it to be different. I should always assume that my source of truth is a system that is to be protected, and at any time I have any uncertainty about the end device, I push its state back down again. And that's only got one database of knowledge to maintain.
Exactly. And I'll give you a little anecdote. This the past 2 weeks here, I've been going through and taking all of our F5 automation, and I have been testing and upgrading for Ansible 2.5. And throughout all of that, as you know, a lot of the F5 modules continue to be developed, and there's some new parameters for the F5 modules in our testing. So I was going through all of our repositories and doing playbook updates to take advantages of some of the new features, like the provider feature in 2.5 and so on. And throughout all of that, I did not log on an F5 device once. I did all of that testing by manipulating my input data and by manipulating my playbook configuration and was able to go through and validate, essentially upgrade and validate all of what we have today to work on Ansible 2.5 and never once logged on an F5 device.
That's cool. And you just reminded me saying that. So I was in Minneapolis yesterday. So I look a bit tired today. I got in about 1 a.m. Giving a talk about network infrastructure as code. So using GitHub Enterprise to store all my configurations and push down. And someone asked me, how do I upgrade my device when I'm doing infrastructure as code? And I said, we don't do upgrades anymore once we're in infrastructure as code. You create the new instance, push the service definitions down to that, and just delete the old one. Yep. The process of having to do an upgrade, and upgrades are intense operations. You're often updating databases. You've got new schema models that are in the new device that weren't in the previous version. I mean, that is an intense process. Whereas I can have this nuke and pave model where you probably pave first before you do the nuke, because there's your backup. But if you just pave to the newer version, delete the old one, again, I haven't even had to bother with that process of migrating or anything. There isn't really a concept of a migration. I just push the service definitions to the new place.
Yeah, and that's critical, and that's a cultural mindset change.
Yeah, it often gets people like mind blown. You see the look on their face when you say we don't upgrade, and they're like, "What?"
Yeah, good, excellent. I mean, excellent point. The other thing that I brought up here too is the fact that, from an organizational standpoint, you really need to, in order to be successful in this Super-NetOps and NetDevOps culture, you really need to look at things a little bit differently. So one of the reasons why NASA was successful, and I don't know if people realize this, but a few weeks before the Apollo 11 launch, the Europeans had a consortium that was also building rockets and trying to go into outer space, and they had actually failed for the 5th time on the launch pad just a few weeks before the Apollo 11 launch. And I was reading the book, A Team of Teams, which is an excellent book. They talk about this, and they talk about how the reason why NASA was successful was because of the way they had organized, so that every individual had some concept of the total system, some awareness of the total system, even though their domain experience might be load balancing or network or compute or storage. And I think that's another critical point. And we talk a lot about how we organize DevOps teams, and the fact that it takes F5 subject matter experts, it takes people with programming skills, it takes people with an architectural understanding, but it's really hard to be successful unless those people understand that total system, what they're trying to develop, right? What we're really trying to do is take a business requirement, add to that data, processes, knowledge, and experience, and come out with some desired state in the infrastructure that meets that need of that business. But I think in order to be successful with this concept of infrastructure as code, you need to be able to have a team that understands the broader picture with specific skill sets in the different areas. So another thing that we need to be successful is this concept of having at least some rudimentary understanding of the whole process, and then how your piece fits together so that you can be successful in working as a team.
That's critical. I couldn't agree more. And I was just thinking of an example while you were explaining that. I've seen many situations where someone will have some kind of service availability or service monitoring system that says everything's up, but actually the user experience is terrible. But because it's not having a systems approach to what is considered up and running, if you're just checking if a TCP stack's there, well, that doesn't check that the application is able to get access to the authorization system and actually get you to the data call that you were trying to make. Well, what is up? you got to have that end-to-end, what is it that it's here to achieve? It's not here to achieve a TCP stack on a service or on a container. It's actually there to be able to work all of those systems together to get the data, to massage the data in the right way that it's useful and present that back out. That's the only time you should mark something as available.
That's exactly right. And this, again, this is, I say the technology is easy. Sometimes it's the organization and people in these processes that's the hard part.
Couldn't agree more. It's a cultural thing. I mean, a lot of this stuff I really do believe has been solved in technology, and it's now us applying it properly and having a systems thinking approach to it.
Yeah, and if you just think of the order of magnitude of the Apollo program, and I think it's interesting on this slide about how many people in how many different countries, thousands of people, thousands of organizations, different universities, how they were able to come together and organize as a team to be able to put the most complex and most powerful machine, the Saturn V rocket, and get it to the moon and back, and would be successful in the first attempt at landing. It's just amazing that you could develop an organization, and it's all about how you organize your team and your management style to be able to do it. And it's something else that we see a lot of our customers struggle with, is how do they organize their IT operations to be successful?
Well, and it's lucky they've got you there to help them with that, Joel.
So the other thing that I think is really important is the concept of your testing, your training, your documentation. So back to our NASA example, these alarms, these 1201, 1202 alarms, they actually encountered those during testing a short time prior to Apollo 11. They actually generated errors into the system, kind of like a chaos monkey concept that we have today. But in their simulators, they tested this condition. And during their testing, the astronauts' reaction was to abort the landing and return back to the command module. And as part of that, Gene Kranz, who's pictured here, became quite adamant, no, I want to know every alarm, and I want to know the correct response to that for Apollo 11. And the engineer who was responsible for that actually wrote down all of the alarm codes from the guidance computer and the correct response to it, and put it under a piece of plexiglass on his desk. And when the 1201, 1202 alarms happened during the landing, they immediately said, we'll go for landing, because we've seen that before. And we know that it is not a critical alarm, but because they had tested, because they had documentation, and they had training, they were able to make the correct decision when it was important to make that decision. So a lot of things in our innovation pod, I've been a real stickler about trying to produce quality documentation, testing what we're developing. And then, of course, we've been at Worldwide, Tyler Hatton and others have been going out and doing a lot of training in conjunction with F5 and some of those training events. But I think that's critically important as well, to not just look at turning over something to the user, but the ability to have tested, trained on that, and provide good documentation, I think is critically important as well.
That is an extremely valuable bit of advice right there. Yeah, couldn't agree more.
So, I'm a big stickler for this, and I spent many years at Cisco writing Cisco validated designs, and we spent a lot of time on doing that. But you would be surprised. From my experience, I had instances where I worked on a solution, and I actually had people come back 6 years later and say, how does this work? And because we wrote it down and had a good documentation on how it should be configured, typically I would go back and say, well, that's on page 37 of this document of how you should do that. And I often thought that in many cases, when you document things, it's not for others, it's for you, so that you think through after or while you're developing something, how do I articulate this? What is my thought process here? And I find that that's critically important in many of these cases, the whole idea with infrastructure as code is that your playbook should be self-documenting, right? The concept of having a higher level in the case of a configuration management tool, having something higher level that describes the state of that system means that if it's human readable, you don't have to write a lot of paragraphs describing it. You can look at a playbook and understand what that system should look like in its configuration.
Yeah, I think also helpful to that is just the way that the social coding and what GitHub's done for the world and how that's helped us down that path. I had someone ask me a question about a protocol, and the whole time I was thinking, why are they asking me? Like, I have no idea why they think I know anything about this. And it turned out it was something I'd committed on GitHub and just totally forgotten about from years ago. And it was only because I did actually do a little bit of documentation on it that they were able to learn enough to ask that question. So I had to go back and read my own documentation myself. Had I not shared that and written it all down and contributed that to a public repo on GitHub, then well, that would have been just total wasted time that I ever did it in the first place.
Right. And I think it's important as organizations get bigger, being able to have some consistency in just how we organize our thoughts, I think makes a big difference.
Just want to check on something though from that. I said GitHub. Is it GitSoft, MicroHub? What are we calling it now?
I don't know. I thought that was rather interesting. That we'll see how that all plays out, because certainly that is one of the more popular websites, and it's becoming critically important to how we manage software today, because the open source software is really the future. So we'll see.
Yeah.
So, just to kind of wrap it up from a high level, to try to explain this to sales leadership, what are we actually doing in our automation pod? Right? We have business requirements. It could be as simple as a developer needs a virtual machine. And we've had some customers tell us that in their environment, it takes 210 days for a developer to get a virtual machine. So if that's our business requirement, that a developer needs a virtual machine, our goal should be central source of truth, one source of truth, databases and repositories, have processes or tasks, maybe some code, maybe some Python code, but for the most part, what we're interested in is playbooks that define the steps that you need to create that desired state in the infrastructure. And then, of course, the key piece is the knowledge and experience. So, very often, and I see this a lot as people are starting out, and I've done this as well. I mean, you start out with a very rudimentary understanding of how to write a playbook for configuration management, but as you go along, just as in programming, you get more experience and more expertise about how you go about doing that. One of the things I did this morning was take a number of playbooks that we're doing for a POC for a large financial, and I went through and optimized them, because I wasn't satisfied with what had been developed as part of that POC, and I wanted to do and provide really good examples for this customer. So, the team that's working on it is doing a great job, but they don't, you need to be able to share back with the other people in your organization. If you know a better way to do something or a more optimal way to do something, that's where that knowledge and experience comes in, so that we can all learn, always be able to learn from someone smarter than ourselves, but then be able to also teach and apply that, so that everything that we do is continually improving our game, improving how that we write this, how we be more efficient, how we architect things. But at the end of the day, we're just trying to create that business requirement or enable that business requirement into infrastructure as efficiently and as in an automated fashion as possible.
I'm a big fan of the continuous improvement part of the whole DevOps culture. I think that's actually really critical and often overlooked. We look at technology instead of actually thinking more about the culture and the process side. And this also came up in that talk in Minneapolis yesterday, when someone asked, like, what happens if I have a failure and I go to troubleshoot, yet I've applied this systems thinking and I have a source of truth now that is, maybe a Git repo or a database, a Mongo database, like you said, and I put all my configurations there. So when it breaks, I mean, I have to troubleshoot down here. How does that work? And I explained to them that if you fix it in the end device, maybe the last thing that got applied caused an issue. And if you just fix it there and then move on to the next problem, the system hasn't got any better. There's been no improvement, no value came out of that diagnosis and that repair. But if you find out what the issue is and you're able to fix it and you bring that change back into the system, then no other device will have that problem again. You've made the system more robust. That's what continuous improvement is all about. You don't just make automation and that's it, I don't have a job anymore. Your job now is to continuously improve the system of deployment and not continuously just patch and troubleshoot end devices where you're not learning from that and applying that back into the feedback loop. So I'm a huge fan of that part. I think it gets overlooked too often, the continuous improvement. So I really appreciate you mentioning that at the end there, Joel.
Well, that comes from the Toyota manufacturing process, lean manufacturing, right? I mean, the concept there, and it's spelled out in the DevOps handbook, but it's really part of lean manufacturing is that if you're not constantly improving, you're going backwards due to attrition. And that's true of your processes that you do, but it's also true of just your knowledge and your learning as well. If you're not learning new things all the time, if you're content to be where you're at, you're losing ground. And in today's environment, you're losing ground very quickly because things are changing so quickly today.
Correct me if I'm wrong, but I remember reading a passage in that DevOps handbook about the Toyota manufacturing process where I think managers were all expected to come up with an improvement to the system every 2 weeks. Did I remember that right? There was something like that in there, yeah.
There were some goals there about how can we improve. And obviously, early on in the process, your improvements are going to have a greater impact than ones later in the process. But sometimes even small changes can make a big impact as well. Certainly in terms of cost savings. I'll give you an example, and I told somebody this the other day. Back when I was a mainframe systems programmer, IBM mainframes, all of the hardware had a little hex key that opened the device, the doors on it. And those hex keys were made out of metal. And IBM at the time had a process where if you saved the company money, you got a portion of that saving. Well, one of the engineers said if you put plastic, if you had a plastic handle instead of a metal handle, it would be less costly. And it ended up being hundreds of thousands of dollars per year because of the savings in just a small trivial thing like a plastic handle versus a metal handle on a hex key. So while you might think that's trivial, when you look at the scale that we're developing some of these things, it adds up. Even pennies add up.
Yep. Continuous improvement. That's the way you capture all those tiny little things that end up the difference of potentially millions of dollars.
So I'll send you the SlideShare link for this, Nathan. There's a number of references in there. If you're at all interested in Apollo and the space program, and I think it's fascinating because a lot of what they did, back in the mid '60s, applies to things that we're doing today. Concept of how we organize teams, sources of truth for data. The whole knowledge and experience standpoint, understanding the architectural view. I think there's a lot of things that they did there that made us be able to, as a human race, be able to land on the moon and come back successfully. But it's good to, I think, look how they organized and how they accomplished that because it applies today.
So Joel, I mean, I've already done a lot of work in network infrastructure as code, but I learned so much about Apollo that this was still really awesome. I had no idea you knew quite so much about it. So thank you for enlightening me down that path as well. I've got a bit of reading I'm going to go do now. That was some cool stuff, especially the way that they were doing the assembly code back in the earlier days. Very interesting. So appreciate your time.
It's all online too. There's links in the presentation. The guidance computer source code is actually on GitHub, and awesome. You can go back and take a look at it. So
awesome. That's really cool. Well, you're a very busy man, especially with the lead up to Cisco Live, I imagine. So I appreciate the minutes you've spared us today. And great topic. Like, what is code? Not just for software engineers, but as it applies to the way we're doing network automation and everything. I mean, that's a really important thing that I don't think anyone's kind of got out there and talked about yet. So thanks again for coming on today, Joel.
Okay, thank you, Nathan. We'll see you. Thanks again.
Awesome. Have a great week. This is Nathan Pierce from REDtalks.live. You've been listening to Joel King from WWT. Thanks for listening.